So peradventure, you see this question in your upcoming UTME in chemistry, and you are asked to answer this question. Now, what would be your answer? It says C plus, which is Coke, plus H2O to give H2 plus CO2. Now, change in Gibbs free energy for the reaction above is 1300 Kelvin. Now, I circle that. Is minus 43 kilojoules. At this temperature, the reaction is, now if you look at this question is very tricky. It tries to shift your attention from this energy change to the temperature. It says at this temperature, the reaction is what? Now the first thing you should keep in mind is this, that a change in Gibbs free energy, first, we have three types of reaction based on their feasibility or spontaneity. We have spontaneous reaction, we have non-spontaneous reaction, and we have reactions at equilibrium. So, for a reaction that is spontaneous, the change in Gibbs free energy is always negative. I hope that is showing. The change in Gibbs free energy is always negative. So I'm going to put it here. For a reaction, a spontaneous reaction, the change in Gibbs free energy is always negative. For a non-spontaneous reaction, the change in Gibbs free energy is always positive. And for a reaction in equilibrium, the change in Gibbs free energy is going to be 0. Alright, so having known this, we'll come back to this and check the energy change. The change in Gibbs free energy there is negative. So our attention should not be on the temperature, but what? On the energy change. Keep that in mind. Now, it now says the reaction is what? A, not feasible. B, at equilibrium. C, feasible. D, exothermic. Now let's explain each of these terms, beginning with exothermic. Now an exothermic reaction is one in which the change in enthalpy is negative. But now here we are not given the change in enthalpy, we are given change in Gibbs free energy. So this does not even satisfy our inquisition. Now the next one says feasible. I'm going to come back to this. So what does a feasible reaction mean? Now at equilibrium, is change in Gibbs free energy 0? If it is not 0, then equilibrium is also out of the case. So now we now come to feasible and not feasible. Now spontaneity of reaction is also termed feasibility of the reaction. So for a spontaneous reaction, we say, for a feasible reaction, we say it's also what? Spontaneous. A spontaneous reaction is a feasible reaction. A spontaneous reaction is a feasible reaction. A feasible reaction is a spontaneous reaction. You can use it to dance. You know what I'm saying? Alright, so the answer, since change in Gibbs free energy is negative, so the answer is what? Spontaneous, which means what? Feasible. Just master that. Change in Gibbs free energy, negative, spontaneous. Change in Gibbs free energy, positive, non-spontaneous. Change in Gibbs free energy, 0, equilibrium. All right. Now, of course, you should also know what is called electrode potential. For a reaction that the change in Gibbs free energy is spontaneous, the electrode potential, the change in Gibbs free energy is negative, which is spontaneous. The electrode potential is positive, just the reverse. You understand what I'm saying? Then the non-spontaneous reaction, change in Gibbs free energy is positive, but then the electrode potential is negative. Do you get that? All right. Therefore, equilibrium is still 0. Now, which of the following is a condition for spontaneous reaction? Which one is a condition for spontaneous reaction? Keep in mind that change in Gibbs free energy is equal to change in enthalpy minus T delta S. T here refers to temperature, delta S refers to change in entropy, and delta H refers to change in enthalpy. Now, so in most cases where this occurs, this guy is usually negative. Is that okay? Or at least, first, recall that I said that change in Gibbs energy must be negative. So for a spontaneous reaction, if change in Gibbs energy must be negative, if it must be negative, then one of these will be true. one of these must be true, that change in enthalpy minus change in delta S. We said it must be negative. If this thing, since this is changing this minus this, then it means that this, both of this must be less than 0. Does that make sense? If both of them are less than 0, then it means that change in enthalpy must be less than T delta S. Does that make sense? So if that is the case, then the reaction is what? Is spontaneous. So he now says that which one is responsible for spontaneity of a reaction? A, that this guy is 0? No. If both of these guys are 0, then it means that change in delta S is equal to change in delta T delta S. So if that is the case, the reaction will be what? At equilibrium. Change in delta S is positive. Now if it's positive, it means that this one is very much greater than this guy. Or at least delta S is positive, is negative. So if delta S is negative, then it makes this one positive, and then this one being positive will make the reaction positive and then non-spontaneous. So the answer is going to be this, that is delta S minus delta H minus T delta S is change in use energy, which is what? Negative. So this is the condition for spontaneity of reaction. Do what to follow my page and subscribe to my YouTube channel. I do all of sciences, physics, chemistry, and math. Do what to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. And also follow me on TikTok, because I'm going to be releasing short contents like this. God bless you as you do so.